Before we leave this section, we're going to take one more look at sinusoidal functions. First, we're going to review some facts about sinusoidal functions that we saw in the last video. Then we're going to do kind of the reverse problem that we did in the last video. We're going to start with the graph of the sinusoidal function, and then we're going to use that to determine its formula. Alright, so first remember that a sinusoidal function is any function that we get from a sine or cosine graph by any combination of our standard transformations. That could be vertical reflection, that could be vertical scaling, stretching or compression, horizontal stretching or compression. We can do vertical translation, moving up or down, or we can move to the left or the right. And if we do those different transformations in different orders, these are the basic formulas that we get. Here is one of the sine versions, one of the cosine versions, the other sine version, and the other cosine version. The only difference between the top two and the bottom two formulas is that on the top two, we do both the vertical and horizontal scaling before the translations, and in the bottom, we do the horizontal translations before the horizontal scaling. Now, in practice, it's usually easier if we do both of the scalings first, both of the stretching and compressions first, before we do the translations. That's just my own personal bit of advice for you. All right, so again, we had some observations about the roles that those different constants played. One of the things we saw about the constant A is it tells us how vertically stretched out or compressed the graph is, and that tells us the amplitude of the graph. B tells us how horizontally stretched out or compressed it is. That greatly affects the period. In fact, it completely determines the period, because whatever that B is, our period is going to be 2 pi divided by B. And that is on the sine or the cosine. C tells us what the horizontal translation is. Does it move to the left? Does it move to the right? And then D tells us the vertical translation, whether it moves up or down. All right, so we got a couple important properties of the sine and cosine graphs, and one is they're basically the same graph. They're just horizontal translations of one another. Next is the period of both is 2 pi. And what we might ask ourselves is, okay, if we want to figure out, if we have a graph and we want to figure out if it's a sine graph or cosine graph, we should really know what a sine graph or cosine graph looks like from the beginning. Of course, what's the beginning of the sine or cosine graph? It goes infinitely in either directions. Well, I'm going to look at just one period of each graph, starting at x equals 0, so we can recognize that from a graph of a sinusoidal graph in general. So here's what the sine graph looks like on the left and the cosine graph on the right, starting at 0. One period each. And so for the sine graph, we start in the middle of the graph, we move up to the top, then down to the bottom, and then back up to the middle to complete an entire period of that particular function. For the cosine graph, it's a little bit different. We start at the very top of the graph, we go all the way to the bottom of the graph, and then go back up to the top of the graph to complete the period. So that's one way of recognizing, do I have a sine graph, do I have a cosine graph for my sinusoidal function? And what we're going to do is we're going to look for those shapes. The start in the middle, go up, down, up, or start at the top, go down, and then up. And those are going to tell us how to do, whether we want to do sine or cosine. All right, so here I'm going to give you a sinusoidal function, just the graph, and we're going to figure out what the equation is for that, what the formula is for that. So here we've got our sinusoidal graph. It looks perfectly sinusoidal. And then, well, I'm going to look first for the vertical center of the graph. That'll tell me a couple things. That'll tell me the vertical translation and the vertical stretching both. And there's that orange line right in the middle going through y equals -1. So that tells us we have a vertical shift of -1. Because if we had a regular sine or cosine graph, that center would be at the x-axis, which is y equals 0. Since we're at y equals -1, that means our vertical shift is -1. It is also going to tell us what our amplitude is, because we're going to start at that middle and ask ourselves, how far do we have to go to the top or bottom of the graph? Well, we start at -1, the top is -0.5, the bottom is -1.5. Both of those are a distance of 1/2 away from that center, which means our amplitude is going to be 1/2. And then the third thing we're going to do is we're going to look for a period of sine or a period of cosine that start at x equals 0. Remember, sine starts in the middle, goes up, down, and back up for a complete period. The cosine starts at the top, goes all the way down and all the way up for a full period. And depending on where you look at the graph, you could find a sine or a cosine. So for instance, see that black portion of the graph? It starts in the middle, it goes up to the top, down to the bottom, and back up to the top. That's a sine graph. And so if we want to think of that as the beginning of our graph, we'd have a sine graph for our function. So that's what a period of the sine looks like. One period of the sine looks like. Now here's another one where we start at the top. If we look at the black portion of the graph, the new black portion of the graph, there we start at the top, go all the way down to the bottom, and all the way back at the top. Well, guess what? That's the period of cosine. Again, that's what a period of cosine looks like if we started at x equals 0. So we have some kind of horizontal shift to worry about here. But still, we have a cosine graph. So depending on how we look at this graph, it could either be a sine or a cosine graph. Slightly different formulas either way, but it could be in either choice. So we'll go ahead and do both, right? I'll start with the sine graph. That's this one we have here, the black portion of the graph. So in our general form is going to be a times sine of b times x plus c plus d. Notice we have the parentheses around the x plus c indicating that we're going to do we're going to worry about the scaling first before the translations. So we already figured out the amplitude is 1/2, and that means a is 1/2, so we can put that one in. The vertical translation, remember, is -1 because it's a distance of, we move down -1 to get to that orange line. So we get d equals -1, and we can just sort of pop those into the equation now. And now all we have to do is figure out b and c. Well, b is going to be not too bad because that is completely determined by the period. Right? If you look at the period, well, we want to go to the left of our, we want to start on the left of the beginning of our period, in the middle, go up, down to the right, and measure the horizontal distance to the right. Well, we got to kind of look kind of closely there about what our x coordinates are. But at the left, we have an x coordinate of -1/2 because we're just to the left of the y axis. And if we go to the end of that period, we're going to be at 5.5. Each of those grid spaces is a distance of 1/2. Right? So we're one grid space to the left of the y-axis, that's -1/2, and then we're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 grid spaces away from the right one, and so that's 11/2 or 5.5. So if we want the period, we're going to take the right part of it, subtract the left part of it, so that's 5.5 minus -1/2, and that gives us 6 for the period. And now that we know what the period is, well, guess what? We also know the period is 2 pi over b, because that's the formula we got for the period. Setting those two things equal to each other, 6 equals 2 pi over b, we can then solve for b. I'll let you do the algebra, and we end up with b equals pi over 3. So now we can put that one in for b as well. So now all we're missing is c. But c is actually pretty easy, because remember, what is c going to be doing? That is just going to be a horizontal translation. How far did we go? Well, look at the beginning of that black sine period. That is at x equals -1/2. In a normal sine graph, that would be at x equals 0, which means that we had a left shift of 1/2. We started at x equals 0, we moved to x equals -1/2. That is a shift to the left of 1/2, which means our c is +1/2. And there we get our formula for our sinusoidal function. All right, so that gives us our sine version. Now, let's go back and try our cosine version. Now, you may be thinking, oh my goodness, we're starting back from scratch. But it's actually not as bad as it looks. First of all, we want to look at the part of the graph that looks like a cosine graph. Again, looks like a cosine graph, a period of the cosine graph starting at x equals 0. And that's the black portion of the graph starting at the top, going all the way down, and then all the way back up. Now, you may think that we have a lot of work to figure out all those constants that we have to figure out. But believe it or not, we're actually 3/4 of the way there already. Because a lot of the things are going to be the same for this graph as they were for the other graph. The amplitude is the same, like the distance between that orange line and the top and bottom of the graph doesn't change because we're looking at a different part of the graph. The vertical translation is the same. All we did was look at the same part, a different part of the same graph. It still has the same vertical translation that we did before. And the period is the same as well, because the period doesn't change just because I change where I start the period. And that tells us that the amplitude is still 1/2. The period being the same says that b is still pi over 3. And the vertical translation being the same means that d is still -1. So those three constants do not change at all. And in fact, the only thing that's going to change at all is that darn little c. Right? And c, remember, that is the horizontal translation. And what we do is we look at the beginning of that period of cosine, and that is at what? X equals -5. It's kind of hard to see, but if you go back to -4 and go back 2 grid lines, that takes you to -5, which is the beginning of that period. And that means ordinarily that part of the cosine graph would be at x equals 0, and that means that we moved that graph to the left 5 units. Since we moved it to the left 5 units, that means our c is a +5. We put that c equals +5, and there's our formula, our cosine version of the formula for our sinusoidal function. So for any graph, you have the choice. You can do a sine graph or a cosine graph. It can still describe the same graph. All right, so now I think you're ready to work on this last set of sinusoidal graph activities. This one's called converting sinusoidal graph to equation.